When you start down the path of delivering analytics for a company, it's typically a request for some set of users or some group to deliver data that they can use to analyze to make better decisions. If you do your job well, this tends to expand. More groups wanting more solutions from more data. As you begin to involve more and more and more data, more and more and more groups and more solutions, this can often and probably should, if you're doing your job well, result in a whole team of people building solutions, often in parallel, multiple solutions being developed by multiple people at the same time to deliver analytics solutions for different groups. There are multiple pieces involved in doing all of this work. You have to extract all of this source data. You have to transform it so that it works well and is optimized for analytics to give the correct answers and to be performant. You have to extract, transform, and load, but you also need a data warehouse solution that handles this data well, and a different layer that handles all of the presenting dashboards and reports and doing analytics and returning that to the business users. Now, there are vendors at every layer competing with different products, and sometimes products are presented that they work well in all of these layers or several of these layers. And not every product is really, to be quite honest, good. Some products are better than others, and some products are a great deal more expensive than others. Sometimes you have vendors that have really good products in this layer or doing these types of processes, but maybe they're not very good in other areas, or they're really expensive in other areas. So what we're going to look at today is a couple of different approaches to getting this data and being able to present it. And we're going to use one vendor and a couple of different approaches with products. One, a massively parallel cloud-based solution using Synapse Data Warehouse and Azure Data Factory. The other, primarily using an on-prem SQL Server database. Now, one more thing worth mentioning, it's not just the end production solution that you have to, I guess, evaluate costs for. There's also the development effort, not only the people doing the work, but also the products that they're doing development with. Sometimes they have to be licensed. They could be very, very expensive pieces, or they could be very inexpensive as well. We're going to look at all of that today in this comparison. So let's get started. We're going to be looking at transforming this data into a model that works well for doing analytics. And on the left side over here, if you'll notice, we're looking at Synapse Data Warehouse. And on the right side is local SQL Server. This is running Microsoft SQL Server Developer Edition on my local laptop. That laptop is pretty old and pretty undersized for this amount of data. We're going to be dealing with multiple tables that have over 100 million rows joined to other tables that have tens of millions of rows, and a bunch of dimension tables that are smaller than that, up to maybe a few 100,000 rows. All of this is going to be done on a laptop that's also recording this video and going to be running all of the analytics solutions for both sides on that same laptop. So it's a little bit undersized, but it does hold up pretty well to this. So let's get started and run them both. We're going to click execute on the Synapse one, and then come over here and click execute on the local copy. And we'll come back when these both finish and look at them. Okay, both sides have completed. This is the data that we were looking at to use when we built our dimensional model. We have a handful of dimensions. The biggest of these is customer, which is 113,000 rows. And to that, we're joining a couple of big stage tables that are 124 million rows each, and another stage table is 32 million rows. They finished on both sides, and they wound up on the local version on my laptop taking about 3 minutes and 54 seconds. On the cloud version that's running Synapse, we wound up taking about 6 minutes and 10 seconds. I should mention that on both sides, the Synapse side as well as the SQL Server side, both data sets have been optimized per Microsoft's recommendations. So indexing and data distribution for both sides have been optimized according to what Microsoft recommends for each. Additionally, the data that we're looking at, we've got a handful of dimensions here. The biggest is customer, and it has about 113 million rows. And to that, we're staging data, pulling data from sales and sales order, which reach 124 million rows, and miscellaneous, which is 32 million rows. So this is the data that we've built into a dimensional model. All of our data has been modeled so that it's ideal and appropriate for doing analytics to both provide reliable results as well as be performant. So let's go to Power BI now and let's look at both of these side by side. We've created Power BI reports against both of these data warehouses. As you can see, again, over here on the left is Synapse, and over on the right is my on-prem SQL Server database, which is again running Developer Edition on my local laptop, which means both of these Power BI reports, as well as the software that's used for video editing, is running at the same time as my data warehouse on-prem. That's going to make this a very skewed, unfavorable experience on the local version. Now, one thing I want you to notice also is that these are not identical. The reason they're not identical is really twofold. One, the data is semi-randomly generated on each source, which means the way that the data winds up getting distributed and laid out is done in a random manner. So the data is not technically identical on both sides. However, it's the same number of source rows and the same size data on both sides. And this is just a demo to kind of demonstrate performance capabilities and characteristics. So it's not important that the data actually matches identically. Also, these Power BI reports, I threw together visuals on both sides of the same visuals, but I didn't necessarily take special care to make sure that the visuals are absolutely identical. So you'll see that they both behave the way you should expect them to behave, but that's not to say that they'll both look flawlessly identical. Now, if we click on anything in any of these visuals, because of the way that Power BI does cross filtering, it will reflect across all of the other visuals. So if we click on, say, this one, the other visuals all reflect the data that we've drilled down to in this visual. And it's the same thing if we come over here to the on-prem version. Notice in both versions, and when we click again, it unfilters that. And again, it works the same in both. And you'll notice as I'm clicking on these, they're both very snappy. The reason they're both very snappy is because I've already clicked on these before we started this video, which means this is really being handled by Power BI's caching and not the source data warehouse. However, if we click on anything in any of these that isn't already cached by Power BI, what you'll see is a spinning little icon in the corner of each of these while the data is being returned from the data warehouse, and it will not be quite as snappy. So if we click on, say, for example, this one, see how this is spinning and it's taken a second for these to return. If we click on another one, we'll do the same thing again, and it takes a few seconds. This may or may not be an acceptable amount of time, but remember, as your data grows and as the number of solutions that you use grow, it's going to put more and more demand on things, and that time is only going to get slower. We have other videos on how to make Power BI and other dashboarding and reporting tools more performant. Those may come into play, and you may need to look at some of those things if your data gets big enough and complex enough that performance is an issue in this reporting interface. If we come over here to this one, you're going to see a much, much greater impact from having to go to the source data. Again, because we've got so much running on this laptop. This laptop is starved for memory, and all of this is having to be swapped back and forth on disk to be able to satisfy these queries. So when we click here, again, you see spinning icons here in each of the corner of these, because it's taken a minute to return this, and it's actually going to take a significant amount of time. This is easily not acceptable. It wouldn't be this way if it was a dedicated on-prem SQL server, but this is what you see when you just don't have enough memory or resources, or the data is too large. This becomes entirely unacceptable, and there are solutions to solve this, but they're outside the scope of this. So what can we conclude from all of this? Well, there are various vendors, various strategies, various approaches, and for the most part, they all seem to pretty much work. The difference is they may not all work the same. Some may work better than others, and costs vary wildly. Even within the same vendor, you can have multiple strategies, multiple approaches. Some will work better than others, some will scale better than others, and the costs can vary dramatically. In this case, almost all of the pre development work that I did was done on a development edition of a local copy of SQL Server. Anyone can download this directly from Microsoft for free and use it to an unlimited degree without paying any licensing at all. Additionally, some customers may have already an on-prem presence and some may not, which may determine whether you build on-prem or in the cloud or a hybrid of both. In most cases, you can use multiple products at multiple layers and only pay for the amount that you use. But that's not to say that saying, well, this is only pay for what you use is the cheaper alternative. It may be wildly more expensive. Figure out what you need to have and what works best for your business. Define those things and then take the time to test the individual approaches and make a strategy that's based on real cost analysis. If you need any help with any of this, feel free to reach out to me. I'm happy to get emails, happy to get phone calls if you want to sit down and have a cup of coffee, or if you need some actual help building some of this, let me know, reach out, and I'll be happy to help you.